Hello students, welcome to experiencetutor.com. Today's lesson is class 11th chemistry, some basic concept of chemistry, part 6.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Our first question is calculate the mass of one atom of nitrogen in gram. To solve this, first we should know that mass of 6.022 into 10 to the power 23 atom of nitrogen is equal to gram atomic mass of nitrogen, which is equal to 14 gram. Therefore, we can write mass of 6.022 into 10 to the power 23 atoms of nitrogen atoms of nitrogen is equal to its gram atomic mass, which is equal to 14 gram. 14 gram. Therefore, mass of one atom. Therefore, simply we can write therefore mass of one atom of nitrogen will be equal to 14 upon 6.022 into 10 to the power 23, which will be equal to 2.32 into 10 to the power minus 23 gram. Therefore, the main point for this sum is we have to remember that mass of 6.022 into 10 to the power 23 atoms of any molecule is equal to its gram atomic mass. After that, we can easily solve this sum. Our next question is calculate the mass of one molecule of methane. This is also the same type of sum. Therefore, we can write that mass of mass mass of 6.022 into 10 to the power 23 molecules of molecules of CH4 is equal to its gram molecular mass or molar mass of CH4, and molar mass of CH4 is 16 gram. We know that carbon's atomic mass is 12 and hydrogen's 1. There are 4 hydrogen, therefore 12 plus 4, that is 16 gram. So similarly, we can find the mass of one molecule. So we can write it here, mass of one molecule of CH4 is equal to 16 upon 6.022 into 10 to the power 23. So on solving we'll get it as 2.65 2.65 into 10 to the power minus 23 minus 23 gram. Our next question is how many moles of H2SO4 are present in 4.9 grams of H2SO4? For that, we need to find out the gram molecular weight of H2SO4. So we know that gram molecular weight of H2SO4 after calculating we get it as 98 gram. Therefore we can write gram molecular weight gram molecular weight of H2SO4 is equal to 98 gram. So we can write that 98 gram is equal to 1 mole. Therefore we can write it as 98 gram of H2SO4 SO4 is equal to 1 mole. Therefore 1 gram of H2SO4 is equal to 1 upon 98 moles, and 4.9 gram of H2SO4 is equal to 4.9 upon 98 moles. On calculating this, we'll get as 0.05 as an answer mole. Our next question is, calculate the actual mass of a water molecule in gram. We know that molecular mass of water molecular mass of water is equal to 18 gram, because atomic weight of oxygen is 16 and there are 2 hydrogens, so 16 plus 2, that is 18 gram. Therefore we can write 6.022 into 10 to the power 23 molecules of water is equal to 18 gram. Therefore 1 molecule is equal to 18 upon 6.022 into 10 to the power 23, which will give us a result as 2.99 into 10 to the power minus 23. gram. Our next question is calculate the number of atoms in A 1 mole of nitrogen, B 1 mole of phosphorus molecule, C 0.05 gram of water. One mole of nitrogen contains 1 mole of nitrogen contains 1 mole of nitrogen contains uh, 6.023 into 10 to the power 23 molecules. Therefore, 2 moles of nitrogen will contain 2 into 6.023 into 10 to the power 23 molecules, which is equal to 1.2046 into 10 to the power 23. It will be 10 to the power 24 molecules. Molecules. Similarly, 1 mole of phosphorus contains 6.023 into 10 to the power 23 molecules. Therefore, or molecules 1 mole of phosphorus contains. Therefore, 4 4 into 6.023 into 10 to the power 23 molecules, which will be equal to 2.4092 into 10 to the power 23. So here one correction, 1 mole only, and it will be atoms, and this will be atoms. Why we have taken atoms here? Because we know that P4, so we one phosphorus molecule have 4 atoms of phosphorus, so we have multiplied by 4 to find out the total number of atoms in 1 mole of phosphorus. Now we'll solve the third sum, where the question is calculate the number of atoms in 0.05 gram of water. So we know the molecular weight of water, that is gram molecular weight of water is 18. So we can write it as 18 gram. 18 gram of water contains contains 1 mole of water molecule, 1 mole of water molecule or you can also write it as 3 moles of atoms. 3 moles of atoms. How come 3? Why 3 moles of atom? It is because water molecule is made up of two atoms of hydrogen and 1 atom of oxygen. Therefore 2 plus 1, 3. So 3 moles of atoms. So the number of atoms, so directly you can write number of atoms present in 0.05 gram of water will be equal to, first we will multiply 3 moles will be 6.023 into 10 to the power 23. So we have converted it 3 moles to number of atoms. Then we have 0.05 gram of water, and it is divided by the molecular weight, gram molecular weight, which is equal to, on solving we get 5.016 into 10 to the power 21 atoms. 21 atoms. So here the catch point is 3 moles of atom. So don't get confused. For this 3 moles came from 2 atoms of hydrogen and 1 atom of oxygen. So 2 plus 1, 3. And rest is same as that of other sums. Calculate the number of molecules in 1 ml of O2 at NTP. We know that 22,400 ml of O2 22,400 ml or 22.4 liter of oxygen at NTP. NTP means normal temperature and pressure. At NTP contains 6.023 into 10 to the power 23 molecules. So 1 ml will contain, in unitary method we can find it out. So 1 ml of O2 at NTP will contain how much? 6.023 into 10 to the power 23 upon, here it is equal to, upon 22,400. On cancellation we'll get the answer as 2.69 into 10 to the power 19. 2.69 into 10 to the power 19 molecules. Our next question is, calculate the volume occupied at NTP by 2.5 moles of carbon dioxide and B 14 gram of nitrogen gas. This is also very simple. So we know that 1 mole of gas at NTP occupies 22.4 liter volume. Therefore 2. Now directly you can write, therefore 2.5 mole of a gas at NTP will occupy how much? Just we need to multiply it, this much data, into 2.5 moles, which is equal to 56 liter. 6 liter. The second part of this question is 14 gram of nitrogen gas. So 1 mole of nitrogen gas, that is 28 gram of nitrogen gas. So 1 mole of nitrogen gas is equal to 14 gram of nitrogen gas. So 14 gram of nitrogen gas uh, is 28 gram. Molecular weight of nitrogen is 28 gram. We have corrected it. It is 28 gram of nitrogen gas. So 14 gram of nitrogen gas will occupy. So 28 gram of nitrogen gas will occupy occupies 22.4 liter of nitrogen gas. So 14 gram of nitrogen gas will occupy 22.4 upon 28 into 14, just the unitary method will cancel it, 2, so 2 will get cancelled, 11.4, so 11.4 liters, 11.2 liters, sorry, here we have done. So we have corrected it, it is 11.2 liters. Our next question is calculate the number of formula unit, number of oxygen atom and the total charge in 3 gram of carbonate ion. So formula unit, first of all we should know that formula unit is equal to mass of the species upon formula mass. Mass, just we are writing mass upon formula mass. Mass into 6.023 into 10 to the power 23. Therefore, we can write, on putting the values, we can get it as 3 upon formula mass is 60, which is again 6.023 into 10 to the power 23. Upon solving, we can get 3.0 into 10 to the power 22 approximately. So Then we can go as number of oxygen atom. Therefore we can write number of oxygen atom. Number of oxygen atom is equal to number of formula unit into 3, or number of formula unit into 3. So you can write it as 3 into 3.0 into 10 to the power 22, which is equal to 9.0 into 10 to the power 22. Now charge in CO3 molecule. So if we want to find the charge in carbonate molecule is equal to 3 into 10 to the power 23, 3 into 10 to the power 22 into 3.2, 3.2 into 10 to the power minus 19, which is equal to 9.6 into 10 to the power 3 coulomb. Here you have to remember that one formula unit has charge is equal to 1.6 into 2 into 10 to the power minus 19. So one formula unit, so remember that one formula unit have a charge is equal to 1.6 into 2 into 10 to the power minus 19, which is equal to 3.2 into 10 to the power 10 to the power minus 19. So here therefore we got this value. We got this value from here. Our next question is calculate the mass of 2.5 gram atom of oxygen. So number of gram atom is equal to, we can write it as number of gram atom is equal to mass of an element upon atomic mass. Mass of an element upon atomic mass. Here mass of an element is 2.5 and into 16. So we can write a so we so mass of oxygen is equal to number of gram atom into atomic mass, which is equal to 2.5 into 16, which is equal to 40 gram. 40.0 gram. Our next question is calculate the number of molecule in 1 ml of carbon dioxide at NTP. So we know that 22,400 ml of CO2 at NTP contains 6.023 into 10 to the power 23 molecules, correct? Molecules. Therefore 1 ml it will contain 6.023 into 10 to the power 23 upon 22400, which is equal to 2.69, which is equal to 2.69 into 10 to the power 19 molecules. Our next question is calculate the number of atoms in 3 moles of ammonia. So number of atoms in 1 molecule of ammonia. So number of atoms in 1 molecule of ammonia is equal to 4, 1 nitrogen and 3 hydrogen. Therefore number of atoms in 3 moles of ammonia therefore number of atoms in 3 moles of ammonia is equal to 4 into 3 into 6.023 into 10 to the power 23, which is again equal to 7.22 into 10 to the power 24 atoms. Our next question is, an enzyme contains 5.6% iron. Calculate the number of Fe atoms present in 1 gram of enzyme. Mass of Fe mass of Fe is equal to 5.6 upon 100 is equal to 5.6 into 10 to the power minus 2 gram. Number of atoms is equal to 5.6 into 10 to the power minus 2, 5.6 into 10 to the power minus 2 upon 56 into 6.023 or just 6.02. After calculating, we'll get 6.02 into 10 to the power 20. 6.02 into 10 to the power 20 atoms.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.